Welcome to myprojectbazaar.com. Now we can going to discuss about the project power generation using DC driven self-excited induction generator supplying the DC load. Now we can going to discuss about the abstract of our project. This paper given to implement the wind energy conversion system of self-exciting induction generator for improve the voltage of constant DC load. The proposed system employs the induction generator driven by DC motor that has been connected to the DC load through the three-phase diode rectifier along with the control system. The control system has used to control the PI controller. The PI controller performs the error prediction and control the non-linearities of our entire systems. The small-scale wind generation is an exactly to improve our power system management systems. So we can take the self-excited generator carried out using DQ reference frame. So this process almost done in MATLAB SIMULINK modeling as processed. Now we can going to discuss about the flow diagram of our project. First we can see about the self-excited induction generator. The self-excited induction generator driven as an inner block of DC motor and induction generator. It is a compound coupled process. So DC motor is run coupled to the induction generator is automatically run the process is generating the AC power. So the AC power transmitted to the voltage source converter. The voltage source converter process to the three-phase diode rectifiers. So we can change the AC to DC converter. So this is one of the process. The diodes are use the uncontrolled turn on and uncontrolled turn off. And the forward and reverse regions junctions occur the breakdown voltage. So we can pass it to the DC power. The intermediate section of the capacitor bank. The capacitor bank passes the some base values of charge stores in the line and the charge discharge line to improve our the DC load. So this fluctuation is not occur to the load. This passes to the buck converter. Buck converter passes to the AC to DC to DC converter. This DC to DC converter is passes to AC load. The AC to AC converter is connected to the common switching pulse. The common switching pulses are connected to the load as reference value given to the PI controller. This is a switching pulse given to the PI controller to external signal of the pulse generator. So we can some randomly turn on and turn off the buck boost converter is a given pulse to the PI controller. So what we can pass it to the DC load. The DC common DC load which is connected to the motor. We can use that resistive load or inductive load is a combination of resistive load. We can use that this DC load. So the combined process will run self-excited induction generator for DQ reference as made that as possible to PI controller. Next we can going to discuss about the running procedure of our project. The proposed system implementation done in MATLAB version 2013A. First to open the MATLAB window and create a new model file. After creating elements as per the circuit diagram of the base paper, the output waveform will be corresponding scopes are connected in the circuit diagram. This is our circuit diagram of the project. This is the entire circuit. The corresponding scopes are connected in that. So all inner blocks are connected to the corresponding scopes. And next we can see about the results of this entire process. First we can see the stator and rotor current of the self-excited induction generator. This is a rotor current and stator current is a very pretty and achieve better performance of this process. Next we can see about the speed. Mainly the speed is a very important of this step because of our given input to the speed. So we can I will give it to the speed of 1440. This is not only given for 1440, so whatever will be given to the numbers. So we can process that with different level of self-induction generator will be generating different outputs. So it's gonna use the speed output in RPMs. Next we can see about the capacitor voltage. This is a capacitor voltage. We can charge, store and discharge of the batteries. So not for batteries, this is a capacitor. So we can charge and emit the charge. This one fully zeros and charge is very level high. So we can around 350 for amplitude ratio. Next we can see about the DC voltage. This is an voltage source converter of the DC conversion process. This output of DC very this is for not for noise. This is an diode rectifier control process. The diode means uncontrolled turn on and uncontrolled turn off. So this is an main noise ejected in this area. So that the forward and reverse region of diodes is on a very low and high, and so that this process will assess that. Next we can see about the pulse generator. This is an buck converter pulse generator. This is on different amplitude levels to turn on and turn off the sequence of triangular waves to turn on or turn off the pulses. I will zoom in it, and axis properties will given applied. So this is an switching pulse to use of PI controller. You can see that as this one sequence ratio. Next you can see about the load current and load voltage. This is a very low voltage, very low current. Because of our load is very high, we can use the resistive load. I will show the resistive value. And the resistance will be very high, so our output will also very less. Our current values are very low, so that is an Ohm's law process as per that applied. Next we can see about the load power. This is current and voltage is applied that this is 20 watts load we can use that this process. This is a constant DC power will be given to apply that.